So thank you for joining us today. As I say, I'm Laura Gage from the North East Automotive Alliance, and in the spirit of collaboration, I'm delighted to be hosting this event today with NEA member Virtual Manufacturing. This session should be very interesting, I'm sure, and we've got quite a lot of people on the line. So if you can remain on mute until towards the end, that would be great. We have left some time for Q&A at the end, of which I'm sure there will be some good discussions as we learn and hear about some best practice across Europe. So we are joined by Daniel Wigren, who's a Sales and Marketing Director from Virtual Manufacturing. Also delighted to be joined by Andreas Rosengren from Siemens and Andreas Johnson from Volvo Cars, who'll be talking a little bit later. So now I'd like to hand you over to Daniel, who will take you through today's session. And like I say, if you've got any questions, please feel free to add any into the chat function or hold them till appropriate time at the end.
All right, wonderful. Thank you so much, and good morning, good afternoon, everyone, and welcome to this co-hosted webinar that we're offering today. As mentioned earlier, I'm delighted to see so many people joining us today, and Andreas ×2, thank you once again for supporting us in this event. We're looking forward to some very nice insights on the journeys that you've been through the last couple of years and some of the showcases that you will be presenting later on. Let me just kick off a bit. I mean, most of you probably know the NEAA, who they are and what they're doing. Maybe you don't know that much about Virtual. I'll just introduce us very briefly. Let's see if we can get there. This is who we are today. So basically, we're working with the digital transformation. We're working with production logistics, developing towards the manufacturing industry. Situated, headquartered here in Gothenburg in Sweden, but working more or less with clients on a global footprint. Established back in 2006. So we've been around for a few years. Not a gigantic company, but have done some interesting stuff towards many different types of manufacturing industries during the years. What are we actually doing? We're supporting within different domains. Our common denominator is the manufacturing industry, so we are trying to help them become more efficient. Sorry about that. And we do have some services and some advisory services and some products and some software that we are supporting with. Along with that, we're also working together with a lot of different partners. One of the partners from Siemens will be presenting here today. Andreas Johnson, you will take the role as hopefully a happy customer. And I guess most of you joining us for the call today are within the manufacturing industry, and I just want to raise a challenge to all of us, and this is sort of a slogan that we picked up somewhere down the years, and I thought it's pretty good because end of the day, everyone that is involved in the manufacturing industry, we sort of have a common challenge, and I guess the challenge that we're all faced with is trying to find out exactly what needs to be manufactured. Ask us the question why we need to manufacture it, and how we should manufacture it, and when they should be manufactured in order to optimize performance and flow with minimal costs and resources. I mean, end of the day, that's what most of us are probably working with in one shape or form. We've had the possibility to do this to quite a few different companies around the world, so some big and some small. But I think at the end of the day, it all comes back to facing that challenge. Right, just to set the scene a bit for today's webinar. I mean, we are talking about digitalization, we're talking about collaboration, and we're talking about sharing experiences that we have been through. Before we start, let's just get some of the wordings correct. So just look at some translations. So what are we actually talking about when we're referring to digitalization, or even in some cases where we're talking about a digital transformation that companies or markets are going through. Definition of digitalization: the incorporation of digital technologies into business and social processes with the goal of improving them. And I think the key word there is actually improving them. There's no it's not like you're going to come to the moon by just introducing digital technologies. I mean, you have to define why and where and how should they improve your process. The second part has to do with the fact that it actually is a transformative process. I mean, it's nothing that happens overnight, and the process itself sort of changes how companies interact with both customers, each other, and often their revenue streams, including both consumers, producers, and suppliers. And I think we'll see some good showcases on this a bit later on from our presenters. What are the pros of digitalization? I mean, if we agree upon the definition, let's ask ourselves what are the pros, or what should we be expecting? Hopefully, we should be looking at things like better manufacturing processes. If we can digitalize the work around manufacturing processes, we are hoping to improve them. Products deliver faster to the market. In other words, we can get our products out on the market faster. We can probably reduce the reaction times to customer feedback. In other words, if we're working in an industry where we expect to get feedback from our customers, that time can be reduced. In some cases, we can even look at the entire supply chain and how we can get benefits from them by some kind of an end-to-end integration. And once again, I come back to the concept of the consumer, the producer, and the actual supplier. I see that we still have some people joining us, which is great. Improved insights. I think if we digitalize some of our processes, we can actually collect more data and get a clearer understanding of what the processes are actually doing. And last but not least, hopefully we will be aiming at getting lower production costs. So those are sort of the pros about digitalization. Of course, there's many others, but these are some that I think we should be looking at in more detail. If we come back to the reasoning behind digitalization, I mean, why should we even look at digitalizing some of our processes, and what are some of the benefits that we're hoping to get out of the digitalization? I'm just going to list a few here, and maybe you will not agree with me, or maybe you will, but it's a deeper discussion. Hopefully, I mean, we are in a transformative process, or in transformative era right now, where even some of the bigger companies, whether it be within heavy automotive or even in the normal automotive world, are sort of suddenly offering brand new services. I think today, if you look at the heavy side of the automotive business and the truck side, and maybe even on Andreas, maybe you will tap into this a bit, but I mean, we're suddenly seeing that if I buy a truck, the services around the truck is almost more important to me than the actual truck itself. And that's I think is a strategy that the truck manufacturers have taken quite a few years ago and are going down that road at the moment. More efficiency, of course, new customer acquisition channels. We're looking at better workflows, improved working conditions for our employees, from C-level all the way down to the operators. We have better products, improved decision making. That's an interesting one. In other words, we're allowing ourselves to take decision based on facts, and the facts are collected via digitalization. Innovation is a key word nowadays. I mean, the more digital we are, the faster we can go through the digitalization or the innovation loops. And last, but of course not least, better teamwork. I mean, if you are working in a global company with factories around the world, or even design centers around the world, the concept of collaboration and teamwork is more and more important. Now, if we compare digitalization versus digital transformation, there are two different kinds of wordings. But I would say that digital transformation is the ultimate consequence of digitalization, and there are some great examples out there that are not locked into the manufacturing industry. But just look at the way that when the internet came, and the way that we're emailing and communicating via social media today. I mean, that's sort of a transformation that the whole world has gone through. Of course, when we're talking about digital transformations, I think the key word is to generate value. And the value that we're looking at to generate once we are comparing, digitalization and digital transformation is, revenue growth. We're looking at speed to market. We're looking at increasing our productivity. We're looking at, customer acquisitions and retention, getting new customers and keeping our customers for a longer period of time. And of course, also improving the competitiveness of our products. And of course, there are industries that are more competitive than others. And I think the automotive industry in general is probably one of the most competitive markets there are in the world. Now, there are some challenges when it comes to digital transformation and digitalization in general. And what we see and have seen for quite a long time, that the whole idea. I mean, nobody has missed the concept around digitalization, but there are some pitfalls that you can actually fall into, and we do see them every once in a while. And typically we see one problem, and that is, when we have these big companies, they spend X amount of money trying to turn themselves into some kind of a, digital company, but unfortunately they don't succeed, or they don't get there, or the timing is not right, or it takes too long time. And the reason behind it, or why this happens, is we see that often it's on a C-level, where you have, CEOs and top executives that are, they see this as a threat, or there's an existential threat posed by digital disruptors, or companies that are working in the similar markets. And the idea, or the thought behind it, is often that we as a company also have to do something gigantic, something big, to respond to what it is that our competition is doing. And that's sort of a pitfall that we see every once in a while, and that actually, it comes down to the problem statement itself. Now, one approach that I just want to bring to the table here is and hopefully we will see some of this a bit later on today, that there is a concept of discovery-driven digital transformation. In other words, where we're sort of not going in with a gigantic, the boom busting, this is the way of working, but instead we're sort of working incrementally. Let's look at where are we actually having problems, whether it be on the shop floor, or whether it be in collaboration, or whether it be in how we are designing both our products and our processes to manufacture them, and sort of take an iterative step to digital transformation. So that's something to be aware of. Last but absolutely not least, I just want to give you a bit of a heads up. We have on a personal level, I have the chance to visit quite a few different factories around the globe, and have been doing that for the last 20 years. And between myself and everybody that's joined us today, I think we can still agree upon the fact that when we're talking about digitalization, and we're talking about the manufacturing industry, and we're talking about the factory floor, this is typically what we see, right? So everybody can say that we're heading down the digitalization road, but end of the day, when you walk out on the shop floor, we see that the shop floor typically is very analog. Even when it comes to data collection, when it comes to collaboration between teams, or even when we're talking about analytics, there's a lot of pen and paper out there. And at the same time, as leaders, we're putting more and more pressure on our colleagues to become some kind of more efficient, become some kind of what we like to refer to as knowledge workers. So take that as a takeaway, and just think about where are our problems, what can we do to solve the problems. Is it a shop floor problem? Is it a collaboration problem? Find the problem and find the solution after that. I think with that said, I'm gonna hand over to Andreas Rosengren. Looking forward to a great presentation. I have a bit of a hint what it is that you will be presenting, and it's going to be fascinating. Thank you.
Yeah, thank you.
Thanks, Daniel.
I don't know if you can see my screen.
Perfect, thanks.
Good. Thank you for having me. My name is Andreas Rosengren. I work at Siemens DI Software in the Nordics. I'm fairly new at Siemens. I've been here for like a little bit more over 2 years, 2.5 years. And since this is an automotive group, I could point out that I usually introduce myself as born and raised at Scania. I worked at Scania trucks for 25 plus years. So it's a little bit at home. So when I'm here to present a showcase basically that we made at Siemens pretty much last year around the industrial metaverse, which is I think most of you have heard the term. It's kind of it's risking being the new hype. It's kind of the continuation of Industry 4.0, the next big thing. But I'm actually quite pleased to say that at Siemens, at least, we have a clear vision of what it is to us, and this is a little bit what I'm going to present today. So, see if this works. Yeah, a little bit of background first. We see, as Siemens, we have a huge portfolio of different products in a rather complex environment. I mean, anything around PLM, design software, simulation, MES, MOM, automation, and there's no shortage of complexity here. And actually, what customers really want is some way to make sense of all this kind of complexity. So, blurring the line between digital and real is really one thing. Breaking down silos, being able to collaborate across these different kind of systems and see things through one single pane of glass, if you like. And also being able to see simulation in a context more resembling real life. So that's a little bit of a background, and that's really what we would refer to as the industrial metaverse. Another a little background picture. I don't know how many of you have been subjected to a lot of Siemens presentation, but we have during the last couple of years at least, we have been talking a lot about this comprehensive digital twin, which for us at least is really a way of framing all the different technologies we have, from both a digital twin of products, digital twin of production, and also the real product and real production, to kind of make some kind of a map or framework around this. And I will return to why this is important. Another thing that's important for us in making sense of our own portfolio is it's also that this kind of works as a backdrop or if you like, for our digital threads, which is also our way of packaging solutions. Because I mean, the portfolio is vast, and there's different ways of combining technologies. So, and a little bit again, what is the comprehensive digital twin, and why does it matter? I mean, a comprehensive digital twin is a precise representation of a product, process, or whatever, any kind of artifacts within our industry. It is actually also used across its life cycle. You simulate, predict, and optimize behaviors of this. And I think that this third point is really important. It's made up of multiple representations. There are no such thing as one digital twin. Often you have one digital twin per use case. So that means that you really have, without a context, you can swim along in your different digital twins. You have multiple of those. And another important thing is it is an evolving object. If you want to have a living digital twin, it needs to evolve. You need to manage this life cycle. And having this holistic approach also enables you to do some closed loop activities with bidirectional connectivity. So this leads us into the industrial metaverse. So for us, Siemens' definition of industrial metaverse is really a place where fast engineering decisions are made, leveraging precise, robust data, real and digital. It also enables collaboration, to experience what it's actually like to interact with the comprehensive digital twin. So it's all about visualization, collaboration. You should be able to collaborate in this environment, and also interact and monitor and analyze your data. I will be a little bit quicker here because the real bang comes in the movie, I guess. And this showcase a little bit of the background from that. We are working in the Nordics with Freyr, which is a Norwegian startup for clean batteries. They are building a big gigafactory up in northern Norway in Mo i Rana, and they wanted to explore a little bit about this metaverse because they were in a position where their primary goal was really to be able to sell the plant as a product, because they are looking for investors trying to scale up production, finding new places to scale their factories. So they wanted to be able to show that they have a little bit more than just ideas. And they had already started, like many companies have, with platforms like Unity or any kind of basically game platforms. Unreal Engine is another popular one. And they, based on our announcement, I think it's now 2 years ago, on our vast cooperation with NVIDIA, they were kind of curious to see what is this all about. And they had seen some showcase where we had done with BMW, just making a really nice looking assembly line for cars. So based on this, we kind of developed a joint project to saw that this is a good opportunity for us, because they're also at a partnership level as a customer with us. So they are using a lot of our technologies. So we decided to go along and develop a showcase together with them. And first, before we look into the actual showcase, a little bit look under the hood first. So basically what our demonstrator consists of, primarily, of course, last year I was down in Hannover presenting this, and having a little bit of the NVIDIA logo, it always makes people curious. Everybody's like, oh, NVIDIA, what are they doing here? So, and the point here is really that we are using NVIDIA's Omniverse as see it as a graphical engine. Because what we do here, we take data, and it's hundreds of terabytes of data from different sources. It could be Google Earth data, as you will see. It's BIM data of the building. It's CAD models of lines, it's machines, it's simulation models, and so on. We bring all this into in NVIDIA's Omniverse and create one super model, which really contains all the graphical representations within the plant. Because this is also something that NVIDIA is very good at, presenting large data sets and also providing functionality for it to look nice, like real-time photorealistic rendering and so on. We also combine data sources from real data. Obviously, in this showcase, the factory is not finished. Those are, in some cases, simulated. A lot of the real-time data in this case comes from our IoT platform, Insights Hub, which you will see. And finally, it's brought into the Omniverse. And then we have a joint data model based on AWS. This is the Twin Maker in the background. And on top of this, also another important part of the foundation is, as we are using Teamcenter, our PLM platform, as a backbone. And on top of this, we have built an Mendix application that kind of ties all this together and creates the user experience. So with that, let's dive in. So what do we see here? When you log into this application, you will first see an enterprise overview. You can see some KPIs on different plants. In this case, we zoom into the Giga plant in Mo i Rana. And we initiate the metaverse viewer. And we start off with a nice fly-in. Here you can see all the Google Earth data and the BIM model in all its glory. And this first bit is actually the only thing that was pre-rendered. Everything you will see from when we pass the threshold into the goods reception here is actually real-time rendered. So here we fly into the factory, come into this goods reception area, and we keep flying. And this first station, we have a mixer. It's an important step in the battery production, mixing the slurry. And in this metaverse user interface that you will soon see when we minimize the picture a bit, it's divided on the different parts. You see the metaverse view, you see the physical asset, and you see the virtual asset. Then you can see the virtual asset is basically the engineering side of things. You have these tabs down here with like all the kind of information connected to this asset. Also, for this example, we will move into the did it freeze or? Oh, okay, sorry, my screen froze. But we move into the OE hub, which is another standard application on Insights Hub. We look at OE, we see that there's a quality issue. We go into another application called as like a quality prediction hub. Where we can, by the help of AI, look at to do some predictions on quality related parameters. In this case, I don't really know. I'm not an expert in battery, but apparently it looks like something with a coating bar gap. Another important aspect of this super model is that we can use it to visualize all kind of different simulation. This example is a CFD simulation made in SimCenter. It's not real time, but we use the same context to visualize it. From this, we keep flying. Fly through this area over to some other robots. We'll focus in on another one. Here we have also showcased for something we call an executable digital twin, which is another technology we have. I'm not going to go into details, but in this case, we can from this asset we can take a look at IoT data. It's time series data for drivers in this case. You can see how that has been behaving. You can see if there are any issues. You can connect these to any kind of system. It could be a maintenance system or anything. But now we look at this streamed video of this. See how it's behaving at the moment. And we do see that there are actually some issues. We will go into another application soon to the asset health and service hub, where we can see how this one has been performing over time from a maintenance perspective. Are there any issues reported to it? And we kind of conclude, there's some anomalies that looks weird here, so there's probably something wrong. So let's gather our brightest minds to elaborate a bit. So we initiate a Teams meeting directly from the metaverse. And here we use the metaverse to have a discussion. We look at these time series data, and there are some simulation models connected to this. So we first look at last week's data, see was there any problems then, and we can then do that simulation, show that simulation overlaid on top of the metaverse. You can see that last week looked fine. So, but something has happened, so we then take the latest data set and do the same. And here we can see that there are some shuddering or some shaking going on in the second axis. So we go directly into Teamcenter and start drilling down inside these assets, see what it could be. So we have a look inside, if you like, and as in most cases, we conclude that there is a faulty bearing. So this is actually a standard functionality in Teamcenter that we accessed from the metaverse. So we go back into this asset health and create a ticket. Tell our maintenance guy, come please change the bearing. And of course, he will do that. Here we see our maintenance guy getting pinged in his team viewer screen. Urgent ticket, the robot picker. He will get some work instructions. He will get the selected screens that we have prepped for him. And of course, he will go and do the work. And from this point on, we can move on to keep flying. We come through the formation aging. First, we stop by this generator. And from this one, we look at another standard application called the Energy Manager, which is another standard application that allows you to kind of analyze the energy flows within your factory. You can see where you get your, in this case, it's electricity, water, and gas. You can see where it comes from, where it's being consumed. Here we make another little bit of an excursion into another application called Optimize My Plant, which is it's really a plant simulation model and discrete event simulation that's addressed as a runtime, and you can feed that with data from different sources. This is actually part of a different use case where we have seen an anomaly, and this production manager will try to find some mitigating actions to be able to kind of recover a bit of the lost production. So he uses this model to test a few scenarios. He tried to add another shift. He can also speed up, just increase the speed, and then test this different scenarios, if you like. And then of course choose one. Okay, let's go with just add another shift or something. From this point on, we move on through the formation aging. A bit of it's basically high bay storage where you store batteries and where you charge them and discharge them for conditioning and measuring. And that actually brings us to the last bit. This consists of two quite large assembly lines for assembly or cell pack assembly, and these are two complete process simulation models where we simulate both robots, PLCs, AGVs, as well as manual labor where we use these two mannequins, our ergonomic study mannequins, Jack and Jill. And I say that main point here is to show that we can treat the manual station just as we would do any kind of automated asset, because the station itself has a lot of aspects or data connected to it. So you can look at KPIs and so on the same way that you would for any robot or whatever. So when we go into the metaverse bit, you see the KPIs and so on. You see issues, but we can also see that there are some studies connected to this one. So in this case, we can have a look at the ergonomic studies that has been done in Process Simulate, and do a bit of an analysis of what's going on, what could be improved. And with that, we're getting sucked out of the building. And that kind of concludes the virtual tour of this metaverse case. And I know this showcase, it's a little bit of everything at once. So it's not really, it could be difficult to show you the exact different use cases, but we are actually, after this, we have already implemented this in our own factory in Erlangen, where we actually have a very nice visitor center also, where you can see how we work with this continuously in our own plant. And with that was basically it from my side. I don't know if there's questions. Maybe we should push the questions to the Q&A part later.
Thank you, Andres. That was very, very interesting. Thanks. And yes, if we can hold any questions for the end, if that's okay, although people can post them in the chat also, and then we'll go on to second Andreas.
Oh, yes, thank you very much.
Thank you
very much, Andreas. Impressive to see how far we're coming. I will share my screen, put this in presenting mode as well. Switch. So I hope you can see my screen right now.
Yes, we can. Thanks.
Perfect. So, Andreas Johnson from Volvo Cars. I will present a little bit how we are working with the virtual plant, a little bit about the history around it, and how we, especially now in recent years, how we're starting to collaborate with our suppliers, and then also touch a little bit on what Andreas from Siemens just presented when we talk about what our next steps are. Just very short about me, working as a solution lead for PLM at Manufacturing Digital at Volvo. I've been within the area of virtual manufacturing now for a little bit more than 20 years. As I said, first a little bit about the history. We talk a little bit about our engineering tools, a little bit about our world-class engineering initiative, and then we finish off a little bit with our next steps then. If we talk about the virtual manufacturing history at Volvo Cars, we are actually celebrating 40 years this year. So we started already back in 1984 with what then was named CATIA Robotics. We switched over to RobCAD in 1990, which later on then became Process Simulate. Started OLP in paint shop in 93, included full offline programming for body in white in 97. 2006, we moved over to Teamcenter as our platform basically for our engineering data. Started also then with a Siemens application called EM Server, which is a database for Process Simulate. 2009 started with robotic path planning with algorithms. Also did a lot more of event-based simulations controlled by signals instead of just having a time-based simulation. Let's see if we can get the next one. Then we developed our own modular-based tooling for body in white, so we can get our fixture concepts up much quicker. 2013, virtual paint, developed together with a company called FCC, which is in collaboration with our Chalmers University in Gothenburg. So basically where we can simulate our electrostatic paint process and the droplets with a much higher accuracy. We also did our first pilots for virtual commissioning to connect our PLC into our simulation models to be able to verify the complete sequences. 2017, we introduced global solutions for VR and AR to be able to collaborate in our global context. And then now, 2019, we started our world-class engineering concept, which I will explain a little bit about what it is and why we did it. And we are also starting now to look into the digital twin, which is a buzzword that everyone is talking about. But we have started to look into that one as well. So really interesting to see what Siemens is doing there as well. If we look at it a little bit what and why we have been doing things. In the beginning, it was a lot about just the technical solutions and the simulation performance, then data access and collaboration, lead time reduction, and now in the end, then it's about to be able to collaborate globally around our data. Our engineering tools that we are using. So the main tool that we are using in our simulation processes is Process Simulate from Siemens. But which also is an important part of our virtual commissioning setup, where we also do then ergonomic simulations for humans, as well as our robotic simulations and offline programming. We also have then our IPS software, which is then owned by Fraunhofer Chalmers Research Center, where we can do optimized and collision-free robot paths with advanced algorithms over a complete line. We can also then have the paint simulation, as you saw in the previous slide. For tooling design, we have CATIA from Dassault. For capacity planning, we use PlantSim from Siemens. And then we have Siemens Teamcenter then as our PLM system. So these are our main engineering tools. So world-class engineering, humble words from humble Swedes. So we started world-class engineering because we want to reach what we at least see as our ideal state, which is then an updated virtual plant over time, which can support different scenarios, and most importantly, maybe seamless integration to our suppliers, that everyone can work in the same IT platform to be able then to support our manufacturing setup. So this is what we used to have in our legacy setup. As you can see, there are a lot of arrows. Many of them are only pointing in one direction, which means that our data stream was extremely disrupted, and we had really poor data exchange with our suppliers. So we had DM server as our database for our virtual plant data, which then included and process simulator and process designer. We could have a one-way feed of engineering data to our parts, our car parts, and our from R&D, from Teamcenter. But then we needed to continuously repeat that loop at every design freeze done. We used AutoCAD for 2D layouts. Plant simulation could receive some data then from EMS, IPS as well, but mainly only exports out from EM server. So what we instead decided to do was to use Teamcenter as our backbone, and then have our engineering applications running on top of Teamcenter. So that is the goal, since R&D is also then having design data in Teamcenter. We could have a much faster interaction between R&D and manufacturing. We can get updates from R&D seamlessly and include that in our process planning. Even then the designers at R&D can load their scope of the car in the plant context as well then. So in Teamcenter then we have our manufacturing BOM, including joining. We have CATIA connected to Teamcenter for tooling design. We have our NX Line Designer application for layout design, so replacing AutoCAD, no more 2D. Instead we are using several representations then of the same object, where we have one object, but you can load it in 2D if you want a 2D view, and you can have a 3D view if you need to work with that. We have our manufacturing process planning application or workbench within Teamcenter to facilitate our process planning, and then we have process simulate and running on top of Teamcenter in this setup. And then we are working on, not implemented yet, but we are working on then connecting plant simulation to Teamcenter and also our IPS applications. And then in the next steps, we're looking at what we can do for shop floor then, with both facilitating our equipment documentation in Teamcenter. So for instructions, maintenance manuals, and so on. And also then how we can utilize electronic work instructions within Teamcenter as well. So having Teamcenter as the backbone is the key to for us to enable the data exchange with our suppliers. So just a little bit on how we treat our, in general at least, our virtual development and how we work with suppliers. So you can say that we have this maturity level of our virtual plant. So from level 0, where we don't do any virtual verification, but we instead can look at standards and specifications basically on for example where joining is performed. The next step is that we do product verification, basically just looking at a weld gun towards car parts, for example. Level 2, we include also then the tooling. Level 3, we look at more of the process verification together with the product. Level 4 for us is then the complete layout of the station. And then we have level 5, which is full virtual commissioning then of the complete station and its surroundings. So we basically divide it somewhere around this area where Volvo has responsibility in the beginning to develop a concept, and then we hand that concept over to a chosen supplier that continues with the development, the detailed development, all the way down to installation and commissioning that. When we look at the key data that we have now in our Teamcenter environment, we have our manufacturing BOM, our bill of process, and our bill of equipment. Volvo is responsible for manufacturing BOM then, including our features, which can be joining or clamping data, for example, across the complete project. When we look at, the bill of process and the bill of equipment, we are responsible for those structures within Teamcenter until we hand over, and then we can seamlessly hand over the responsibility of that data to the supplier immediately in Teamcenter then. And then later on take back that once the project is delivered and approved. So basically then with Teamcenter, we have all our data is managed and within our Teamcenter environment as Volvo. The environment is hosted today in Azure Cloud with service in Amsterdam. And then we have distributed local cache servers around the globe to help with performance when we load mainly then heavy CAD data. So we have our MBOM, bill of process, bill of equipment, and process simulate studies all hosted within our Teamcenter environment. And then we have our suppliers connecting to our environment using VPN then. So they will work directly with our data. We don't have to do any import or export, which previously took massive amounts of time. And the suppliers will then only see data relevant for their scope that they are delivering then. So on the supplier side, we have Teamcenter clients where they manage the data that they are supposed to manage. And then we also have then, they have installed engineering applications, which is then directly connected to our Teamcenter environment. And we are now running the first projects with suppliers both in Europe and in Asia currently. If we look a little bit to our next steps and the digital twin then. So if we look at this is just how we see it. You can agree or disagree. If we look at our development process for the car, we can also see the same development process for our plant, basically. We have a virtual development phase where we need speed and flexibility. This is where world-class engineering is present and in this circle to the left. And then once we come closer and closer to installation, we have our physical development as well, which is basically a little bit more rigid, and we need a little bit more robustness when we actually are going to produce something. Our virtual plant we build up during our virtual development, but that one continues to live on and is constantly evolving as well as we make changes during production. Once we have started up production, we also get massive amounts, as Andreas explained, of IoT data from our production and from our machines. And that's when we then can create our digital twin plant, which we then can feed with data, both from reality and from our virtual plant then. And this here then is what then will become this metaverse, as Andreas has explained. So this is our take on it, and that is basically what we are looking into now for our next steps for our virtual development, and then later on connecting it to our physical plant. Yes, thank you. I will stop the share here.
Thank you, Andreas. Another fascinating insight as well. Daniel, do you want to do any kind of wrap up on
maybe
that?
Just to wrap it up a bit. I mean, I think what we've seen today has been some great examples of I mean, both when we're talking about Freyr, which is a gigafactory, sort of a startup company, and their business model is based on the fact that we're going into the electrification world that more or less all of us are being affected of, not at least the automotive business. And coming back to Andreas, I mean, I think the key takeaway there is that the whole concept around the virtual plant is something that's been in development during, what do you say now, almost 40 years. And I like the statement world-class engineering. I mean, you got to aim high to get high, or to get in to come far. And I know there's been a lot of work around it, and I think the key message is to start somewhere, find your pains and do something about the pains that you're having. Irrelevant if you're a small manufacturing industry or if you're a larger global manufacturing industry.
Yeah, for sure.